So thanks for being here. My name is Maarten Mulders. I work with InfoSupport in the Netherlands. We're an IT consultancy firm, and I'm here to discuss DAPR with you. We're roughly 36 years old by now, and we the company. And we decided we're so passionate about technology, we will create our own sauce. So that's the thing you see there. We created a barbecue sauce, which is just as spicy as we think technology in general is. That's why you find it there. But today we're going to discuss DAPR. Why DAPR? Well, let me start with a little introduction about what I do. As I said, I'm a consultant. I typically work as an architect on a project that we run with our clients. And that's part of my job to tackle complexity. In fact, that's part of the fun of my job to see this complexity that we run into with business projects, and then decide how are we going to tackle that complexity, to address it. But if I say complexity, that's a bit ambiguous. There's two meanings for complexity, really. Because yes, I do love complexity, but not all complexity. There's essential complexity, which we inherit from our business domain. The business runs a complex business, and that's why they ask us to help them solve it. But there's also I would say the accidental complexity, the complexity that is not there from a business perspective, but that we as developers and architects usually more or less create ourselves. Because especially the last 5 or maybe even 10 years, it seems to be kind of a default thing to go for a distributed architecture and say, yes, of course we're going to do microservices because, and then obviously we have a lot of reasons to go for microservices, but doing a microservices architecture, or a distributed architecture as I prefer to call it, introduces new complexity. And that complexity isn't there from a business perspective. They don't know about microservices. They don't know about distributed systems. They only know that their own business domain and the complexity that it brings. And it's this accidental complexity that, it's there. Sometimes we created it ourselves. Sometimes technology that we selected brings us the complexity. That's not the interesting part for me. The part that I really like is understanding what the business is about and why their problems are so hard, and how we can build software solutions that make those complexity disappear a little bit. So essential versus accidental complexity. And to give you an idea of that accidental complexity, let's look at a very simple architecture diagram. This is not any formal specification, of course. This is just the typical whiteboard diagram that you could see. We're building some kind of an application here. And of course we want it to be highly scalable because, well, scalability, everybody needs scalability, right? Even if you're not Netflix or Google, you still want to be able to respond to changes in traffic. So our application is going to be able to scale by adding more instances of it. But our application needs to have a certain state that it will keep in memory. It doesn't necessarily need to live in a database or something. But as soon as we are going to scale out, and we want to avoid sticky sessions because that limits the scalability a little bit, then we run into a new problem. And this is accidental complexity. We went for multiple instances. We don't like sticky sessions, so we need some kind of a state store. We need a place where this little piece of in-memory data that we want to keep during the application lifetime can be stored and can be shared between multiple instances of our application. And as soon as we draw this picture, it raises new questions, because what kind of a key value store is suitable for our purposes? It must be something that lives outside of our application process let's say our JVM for simplicity. But then what are we going to select? Are we going for Redis? Is PostgreSQL a good choice, or Hazelcast? Or if you're running on Azure, you could go for Cosmos, or on AWS, you could go for Dynamo. And there's plenty of choices for this very simple use case of doing key value storage. Just a simple, here's one key, and I want to associate a piece of data with it. Accidental complexity. And this is not what I want to spend my whole day on, because as I said, I prefer this other type of complexity. This is a picture that I took from the Jconf, a conference in Barcelona, Spain, where I did the same presentation. And as you can see, it's me on stage discussing this particular picture, which is me not on stage, but me in our offices in the Netherlands, where there's a poster of me on the wall saying in Dutch, but I'll translate for those who do not master Dutch, architecture is all about making choices, but it's better not to do it too soon. If you can postpone it, it's often better to postpone the choice. And that's what we will be discussing today, because DAPR is a way to help you postpone these choices. Going back to this diagram, as I said, we just want to have a simple key value store. So the natural reflex would be to introduce some kind of an interface for key value storage and say, well, maybe we can plug in either Redis or Hazelcast or Cosmos DB into that interface. Something like the Java util map would probably suffice in this case, but for more complex use cases, you probably need to roll your own interface. So if there would be just a standardized API for key value storage, that would be really great. And then we can just plug in any implementation. And if we decide at a certain point, hey, PostgreSQL, that wasn't a great fit, then we can just swap it for Redis or the other way around. Whatever we chose first, we're not coupled to that particular choice. Great. And now, this is where I would like to introduce the dinosaur from the title of the talk. Because if you are a little longer in the industry, you may have heard about the all-new J2EE platform, which was released in December 2003. Later known as Java Enterprise Edition, now known as Jakarta EE. It was initially released in 1999 even, and it set out to create a standardized API for building portable applications. And portable is the essential word here, because the whole idea they had was, we have an enterprise application, and we don't want it to be tied upon a particular implementation for, let's say, a database or a message bus or an application server where we are going to deploy it. So J2EE set out to give standardized, abstract specifications and interfaces, and then vendors could just plug in their implementation. If we talk about databases, for instance, we have JDBC, which was part of it, even part of standard Java, by the way. And every major database vendor offers a JDBC implementation. Is it SQL Server from Microsoft? Is it Oracle database? Is it PostgreSQL? They all have a JDBC driver. And as a developer, I program against the driver specification, not against the implementation. So going back to what we just said, hey, we need a standardized API for a key value store that does not necessarily live in the same JVM. Isn't that just what Jakarta EE was all about? Maybe DAPR is just a different thing than a competitor even for Jakarta. Well, let's see. Your typical Jakarta deployment nowadays could look like this. You have your application logic, which is this tiny little box over there, which is then deployed in a Jakarta container, which is deployed in a Java virtual machine, which is in a sense also a container, which is deployed in a Docker container, which is deployed in a hypervisor, which is also kind of a container. And well, you can see why they say it's a container era, because there's lots of containers for actually a relatively small application there. All those other layers, whew, that's quite a lot. And do we actually need all of them? Because this is all complexity, again, that we need to manage somewhere in our project's lifetime. So the question is, can't we make it a little simpler? And this is where I would formally like to introduce you to DAPR, the Distributed Application Runtime, which describes itself as, and I'm just quoting their website, event-driven portable runtime for building microservices both on the cloud and edge, where edge, in this case, I think they mean on-premises environments. So let's dive in a little bit and see what DAPR actually is. DAPR is a project which is now in the process of incubating to the Cloud Native Compute Foundation, which, well, if you're sensitive to buzzwords, you'll be happy to use DAPR because it's open source, it's polyglot, means it's not tied to one particular programming language, both in usage and in contributing. It's very modular in its setup, it's pluggable, it's cloud native, and traces of nuts, gluten, and Ortnet, that's the wrong one, I guess. So, again, DAPR. The main concept in DAPR is a building block. A building block is basically an abstraction of any cross-cutting concern that you may encounter if you build a distributed system. So, if we go back to the example at the beginning, my concern would be, hey, I need a key value store. And I don't really care about the implementation, just give me key value storage, that's all. And the building block comes with an API. And the API is, in DAPR, it's always a REST API, although they also allow you to interact using gRPC, but for now I'll focus on REST because it's a lot easier to read for the human eye. So if we look at the building block API for key value storage, or as they call it in DAPR, a state store, then the API for actually putting something in my state store is that I need to do an HTTP post to v1 state, which is the name, which is a reference to the fact that I'm using the state store API, and then the name of the state store, which in this case is vehicles. I'll ignore the host for a little minute. And then I'm going to provide a JSON array with elements that each have a key and a value. The key in this case is a unique identifier for the piece of for the piece of data that I would like to store and under which I can retrieve it later. And the value in this case is again a JSON payload, but could be anything. You could throw in binary stuff there, but it's a little bit hard to read, so better base64 encoded. Could be a string literal, could be a number, or could be a complex object, but then again, preferably serialize it. And the API will respond with no content. But it will say HTTP 204, 200 range means okay, and 4 means no content. So I got it, I stored it, and I'm not returning you anything. And again, there's also a gRPC variant for the same API, but given that gRPC is a binary protocol, it's hard to visualize that on the screen. And now if I want to retrieve something from the same state store, I'm going to issue a GET request to the state store named vehicles. I pass the key under which I previously stored the value, and the API will respond with 200 OK, saying here's the piece of data that you stored earlier, and I'm getting my same string literal back, which again for the human eye is easy to recognize as being a JSON payload. So how does that work? Because there's GET requests and POST requests, and then it says host, localhost 3500. Well, that works because DAPR leverages the concept of sidecars. And the sidecar is a process that lives next to your application. Actually, it kind of belongs to your application, and it offers you the connection to the DAPR runtime. And you interact with the sidecar using HTTP or gRPC, as I mentioned. And the sidecar actually provides the implementations of these building blocks. If you run in a Kubernetes environment, you could typically see the app and the sidecar as two containers inside one pod and deploy them together on the same worker node in Kubernetes. But as I said, you don't have to run DAPR in Kubernetes. You can run it outside of it as well, and then you just need to make sure that you start the sidecar yourself rather than rely on Kubernetes to do it. As I said, the building block provides the access to all those implementations. And that means that for each building block, we have a lot of implementations. If we look at the state building block here, we have an API that we just saw. That's the post and the get. And there's many implementations, each relying on a particular piece of technology. So there's an implementation of that API that leverages Redis. There's one that leverages Hazelcast. There's one that leverages PostgreSQL, and so on and so forth. But as an end user of DAPR, I don't need to care about those implementations as long as somewhere I specify that this particular state store is implemented using, for instance, Redis. And in a way, you could say that what DAPR does is kind of the same idea as a service mesh. Service meshes is the concept in Kubernetes where every application pod has a sidecar, which provides you with connectivity to other pods. But that's on an infrastructure level. And DAPR goes the next step and provides you a service mesh for platform, basically. That's an idea I took from Rustam, so credits where credits are due. He said, what you just told me, that's basically a service mesh, but for platform services, platform offerings. And that's a great way to summarize it. It decouples my application from the platform services I would like to use. Now, this is all still a bit vague and abstract maybe, so let's just look at an example and see what's happening. The domain I would like to introduce to you is the domain of speeding controls, very familiar for the Dutch people, and maybe here in the United States they have the same concept as well, I don't know. The way they do it in the Netherlands, they have cameras above the freeways that just register every vehicle that drives underneath it, register the license plate and the timestamp when the car passed, and then a few kilometers ahead there's a second installation, cameras, register license plates, and then it's a simple matter of calculating the time between the two instances where you passed a camera, correcting for the distance, and then calculating how fast you drove on average, and if that's too fast, you will get a fine. And that's also how we implemented it in this demo. I have two cameras which send pictures, or actually the extracted information from the picture over MQTT to the traffic control service. The traffic control service calculates how fast you drove. If you drove too fast, it publishes an event saying, hey, this car drove too fast. Fine collection service, please make sure that we will eventually collect a fine. And to be able to do that, the fine collection service needs to know, hey, who owns that car? And that's where we have the vehicle registration service. So, as I said, demo, which is always a bit of a fingers crossed moment. So if you would please keep your fingers crossed with me, then we'll dive straight into the demo. What I'm going to do here, I'm going to start my traffic control service, like so. That went a bit quick, maybe. It says DAPR run here at the top. And it says that my application will listen on port 6000, and the DAPR sidecar is going to run on port 3600. And then it says component path DAPR components, which is a pointer to a directory that contains the DAPR configuration. Now here I need to simulate the entry of a car, which I do using a simple HTTP post. So I'm saying there's an entry cam somewhere, and look at that, in lane 1 I saw a car passing by with a license number XT346Y, and the current timestamp is this particular value. Great. Now we can go into Redis, because I'm using Redis as an implementation of the state building block, and I can ask Redis, hey, do you have data on this key here? Control service 346Y. Say again? Ooh, thank you. Service is misspelled. Yeah. My fingers are not yet used to the smaller keyboard. So what it says here is HGetAll, that's a Redis specific thing. Traffic control service, that's the name of the application that actually wants to use state. And then XT346Y is the key under which I stored the state. And look at that, I get back a bit of data from Redis with the string that I stored inside it, license number and entry timestamp. So far, so good. Now I'm going to do a second call, and I'm saying the car continued to drive and eventually drove past the second camera, which we named the exit cam. Going back to Redis, and lazy as I am, just copy pasting from there. Now we see that the state has been updated. So in the second call, the Java application was able to fetch the state from the state store, update it, and write it back into the state store. But the code has absolutely zero references to Redis. It doesn't even know that there is such a thing as Redis. And if you don't believe me, by the end of the talk, I'll have a link to the whole code. You can inspect, you can grab whatever you like. There's no reference to Redis at all. So far, so good. Our demo application was able to store and retrieve data in a state store, but it does not know the implementation of the state store. That's the main concepts of DAPR. It's time to explore DAPR a bit further, because state storage is a relatively simple thing. DAPR has a lot more building blocks to offer. We already discussed the state store in great detail. There's service invocation, pub/sub mechanisms, bindings, secrets, name resolution, middleware, and they're adding configuration management at this moment, but I think it's not yet finished. If you take a grand total of all the underlying implementations, including those that are tied to a particular cloud vendor, they have more than 27 very different implementations available, each focusing on a particular combination of a building block and some technology that implements the building block. So service invocation, we didn't discuss that one yet, is the very simple pattern of two applications that want to interact with each other, where one application sends a request to another one, and the second one sends back a response. Now you could say, well, there are simple REST APIs for that, yes, but then the applications need to know about the name and the address of the other one. Whereas DAPR allows me to say, okay, I know there's another application running, here's the logical name for it, I don't know about its particular protocols, but just invoke their get vehicle information service for me, and I want to have back the response. Without knowing whether it's going to be a gRPC call, a GraphQL call, a traditional REST call, or maybe something else, as I said, the underlying transport, it's all abstracted away for you. pub/sub is the pattern where I have one application that signals something happened in our business domain, and it does not know who exactly needs to be informed about it. And maybe the set of application components that need to be informed about it varies over time. That's all fine, because app 1 can just publish the event on any kind of messaging infrastructure, and other application components can subscribe to those events and react as they see fit. And they do that by subscribing to the topic, and whenever an event is published on that topic, they will get a copy of the event and they can do whatever they need to do. But the good part is app 1 does not know about app 2, 3 or n, and on the other hand, app 2, 3 or n do not know about app 1. They only know that at some point in time there may be an event about a speeding violation and they need to do something on it. Bindings is actually a very broad term, and in fact there's a lot of different implementations that do a lot of different things. It's good to mention that there are basically two categories of bindings. There are outgoing bindings, like for instance emails or web services. So my application can send out an email without needing to know about SMTP or mail relays or all that kind of stuff. It doesn't even need to know where the server lives. It invokes a REST API saying, I have a recipient, I have a subject, I have a message, do your thing for me. I don't want to be bothered with the details. Same for web service invocations, like traditional SOAP calls or so. But there's also incoming bindings, and the most easy one to understand, I think, is a cron binding, where I can define a pattern for periodically returning things to happen, and then every time the cron schedule happens to fire, my app will be informed by that and saying, hey, I don't know what you need to do, but you want it to be signaled every 30 minutes, and well, we just passed another 30 minutes. So do whatever you want to do, but your app does not need to have the scheduling component or any kind of background process that reacts upon it, because from your app perspective, it's just an incoming HTTP call, which originates from the sidecar, saying, hey, 30 minutes have passed, hey, 24 hours have passed, or it's the first day of the month again, don't forget to submit your timesheets. Oh no, applications don't submit timesheets. So bindings can be two-way, outgoing or incoming. Secrets is also very powerful, especially for cloud deployments, but I think for on-premises deployments they're just as relevant, where your application needs to have a password for something or a key pair. Well, you want to store it in a secure place, but your application needs to be able to access it at runtime. Well, you can use Key Vault or what's this HashiCorp thing called again? I forgot about the name, never mind. There's a lot of products available for it, but then again, you're binding your application to that particular piece of technology. Whereas DAPR lets you say, okay, my application needs to have the password for this or that, get it from the secret store, and I don't know what implementation is under it. So let's look at a more complex example where we leverage service invocations and output bindings as well. I'm going back to the diagram again. As I said, whenever a traffic violation has occurred, the traffic control service will determine that it has happened, and it will fire a pub/sub event saying, this license, a car registered under this number, drove over this freeway with this number, and this is the speed that I calculated for that particular car. And the fine collection service will need to look up the information of the owner of the car, and for that it uses a service invocation to the vehicle registration service saying, hey, I want to have the details for that car. And then it will use the output binding to send an email to the owner of that car saying, hey, we detected that you drove too fast and you will have to pay a fine for that. So again, we're going to start a few application components, and then we are going to start a simulation that just mimics lots of cars passing by. And if all goes well, we will see some emails flowing into our mailbox. So back to this one's still running, that's great. Here we are going to start the fine collection service. Starting it looks pretty familiar to starting the traffic control service. So again, we say, run me an application. It listens on port 6001, and the sidecar needs to listen on port 3601. Since I'm not running in Kubernetes mode here, I need to do the port bindings myself. I need to keep track of which application and which sidecar listen at which port. But if I would use the sidecar pattern in Kubernetes, then Kubernetes will manage that for me. Here I'm going to start the vehicle registration service, and I think you are starting to see the pattern, so I'm not going to discuss it again. And they all seem to be running great. And now I have a simulation here, and as I said, it's going to mimic some traffic on our freeways. This is interesting. It didn't do that earlier. Why? Simulation spring. Oh, wait. Columns and dashes. Always difficult. Maybe it's better like this. Spring dash boot colon run instead of the other way around. Yeah, there we go. So, as I said, it simulates cars passing by the two cameras, and you can see it says simulated entries and simulated exits of vehicles with license numbers in a particular lane. Nothing to be scared about, but our traffic control service says sometimes, hey, look at that, a speeding violation was detected. There we have one speeding violation by 90 HPL8. And it was 15 kilometers per hour too fast. Now, our fine collection service will be notified of that using the pub/sub mechanism, and it will retrieve information about the car and eventually send out the email. Let's see if those emails actually arrive. And indeed, this is the mailbox that I'm monitoring for it. The mailbox is just a catch-all one. Obviously, I'm not going to send out emails here because then we would probably be marked as a spammer. So, this is just a made-up email, of course. If you do drive too fast in the Netherlands, I think the email looks different, but I never ever do that, of course. But it shows information about the car. It shows information about the owner of the car, and it says, hey, this was the date and time, and this is the speed that you drove, 45 kilometers per hour, which is so much too fast that we don't even know the sanction amount yet. The prosecutor will tell you at a later point. 45, let's see if there's somebody, oh, here, this one drove 15 kilometers per hour too fast, and it's only 130 euros for them. So, that's looking great, everything's working, excellent. Now, if that was all, I would say, okay, nice, but DAPR has to offer more. And the thing that I'm really think where DAPR offers a lot more value is in terms of observability. If you've ever built a distributed system yourself or collaborated on one, you know how important it is to be able to actually observe what your application is doing at runtime. And for me, observation basically comes in two flavors. There's tracing, which allows me to do a full trace of one particular request through all components in the chain. So, user submitted an HTTP request, or they called a particular action. How did that actually evolve through my distributed system? Which components were hit? What did they do? I want basically to see all logging for that request, no matter which application fired it. And there's metrics which give me an overall idea of how healthy is my system. I have 60 plus components running. Are they all doing fine? Well, just give me an overview. So how tracing typically works is that with each request in your distributed system, you inject a few custom headers, and there's standards that actually dictate the names of the headers and the exact values that you should pass. A popular standard, for instance, says that you need to pass XB3 trace ID or XB3 span ID. Let's not dive into those details for now. But it allows you to correlate things that happen in application 1 with things that happen in application 2, given that they are part of the same chain of operation. Now, this tracing, you can use it to enrich your logging, but even if you do not do that, then the very basic what you get here is timing information, which can already be very valuable, because all those applications that are hit in the chain will collect, like, okay, the request came in and something went out, and then at the end I returned a response to whoever called me. And that timing information is then kept by that application and periodically collected by a tool like Prometheus, and then shipped to, or actually visualized using a tool called Zipkin. And it allows you to visualize how the time that the end user sees, hey, why did it take me 45 seconds to get a response on my HTTP call? Where was that time spent? And we'll see a demo in a few seconds. Metrics are a bit different. They allow you to collect all kinds of measurements about your application, so not about one particular call that was made to your application. And then those metrics also are scraped from the application components, so they are collected and visualized in a tool called Grafana. Now, DAPR itself also exposes a few additional metrics, such as how much CPU or memory am I using, if I'm running in secure mode, how often do I need to get new certificates, and do I actually get them from the certificate controller, and how is my sidecar doing in general. And the metrics can be used to visualize it a little bit like this. I'll just stick with the screenshot for now. But what you see here is, my sidecar uses very little CPU in this case. It's microseconds that we're talking here. Memory usage is in the tens of megabytes, which is relatively few compared to your typical Java JVM application. And all my services are running just great. There's no new services spawned whatsoever. Now, tracing, as I said, is also offered by DAPR, and the good part is that, I should say, the idea is that DAPR actually takes away the burden of doing these header injection stuff. And if you run DAPR with the .NET platform, it works out of the box. So you have your .NET application, you add the NuGet package for DAPR, and it integrates fully automatically. The bad news is that for the Java SDK, it does not work out of the box, and you need to do a few custom things. But the whole idea is that by only passing an AX-DAPR request ID, DAPR takes care of the rest and takes care of keeping track of where was that time spent. As I said, the Java SDK does not provide this out of the box, so we need at this point still to add this context write method every time we use the DAPR SDK, which I think is a bit of a shame. I think the integration should be better. I've actually raised an issue about it, like, hey, can we provide a better developer experience here? Because this doesn't make sense. This DAPR client is something that you can fetch from Maven Central. It's called the DAPR SDK, and it lives under the IO DAPR group ID. And it provides you with a DAPR client class, which provides various methods for example, service invocation like we see here. But as I said, the tracing is unfortunately not working out of the box. Who knows in the future. Also, subscribing to PubSub is something that you could do using the DAPR SDK. The thing is, in Java, if you build an application that needs to respond to HTTP calls, incoming HTTP calls, there's no standard for that, or well, there used to be, because that was the servlet API, but nowadays a lot of people use, for instance, Spring and Spring Boot, but people also use Quarkus or Micronaut or MicroProfile, so they have a different SDK for Spring Boot, which allows you to declare an add topic annotation on your method, saying, hey, I want to subscribe to the speeding violations topic, which lives on the pub sub named pub sub in this case. As we all know, naming is one of the harder problems in IT. And if there's an event on that topic, then I want this method to be invoked, and I will get a request body that is of the type cloud event, which is basically a wrapper around the speeding violation, which contains the actual data of the event. For now, they only have a Spring Boot extension to the SDK, but I could imagine they will create more when there's demand for it. So let's see what that looks like in practice. The demo is still running, so by now we should have collected more than enough information. This is Zipkin, and well, this is Zipkin when you initially load it. You first need to run a query. You can do that based on some tracing information that you get from a diagnostic run, for instance. But if you do not pass anything, you can just run the query, and then it will tell you, well, these are the last 10 results. Here's an exit camera trace of 10 spans, and I know because I created the demo that this is the scenario where somebody drove too fast. There's also exit cam with 4 spans, and that means the driver did not drive too fast. So let's look at this one. And this is the typical kind of tracing information that you might get. So you see there's an invocation of the exit cam binding, which resulted in a get state and then a save state, then a publish event call. This is all DAPR calls, as you can see, and you can see they are insanely fast. It's measured in the microseconds. Then the publication of the event took a little longer, 129 milliseconds, but that's asynchronous, so our end user doesn't see it, which resulted in a call to the collect fine endpoint on the fine collection service, which is from their perspective seen as just an incoming HTTP post. And they eventually did a service invocation to the vehicle registration service saying, hey, give me the information about that vehicle. So that's what the tracing information could look like. You can even get a live visualization of what your traffic looks like. Well, this is a relatively simple scenario, so we only see 3 application components. No, that doesn't really help. The traffic control service, the fine collection service, and the vehicle registration service. And we see traffic flowing unidirectionally as we would expect in this application. So, with all that, I think it's about time that we get back to our initial question: is DAPR a dinosaur? In the sense that it is, well, an old idea, but just in a new fancy name? Or is it a developer's dream come true, where it really addresses all the problems that we want and that we need, and maybe even more? A dinosaur, I would definitely say no, DAPR is not a dinosaur, because it addresses a different type of problem than Jakarta EE does. Jakarta EE is really focused on the infrastructure level, where you want to abstract away from this database or that database, or a third one, or this message bus or that message bus. But it's always very technology centric. It says, I have a database, I already know it's going to be a relational database. Now let me abstract away from that. Where DAPR says, I don't really care about the technology. You have a cross-cutting concern. You have a distributed state store. You have the need for a distributed state store. You have the need for a pub-sub mechanism. And whether that is going to be Kafka or RabbitMQ or some cloud platform as a service offering, I don't really care, but I can do all of them for you. So it's not the same thing as Jakarta EE in any way. It's addressing a different type of problem. Then the other side of the spectrum, is this a developer's dream come true? Will this really significantly make our lives easier? I would say no again. And that's for me really based on the developer experience, where if you would like all the good things that we have seen and all the convenience that it could bring, then you expect an SDK to work out of the box. Add it to your project, it works. And I've seen just a bit too often the situation where the docs say, okay, there's an API for that, of course, because DAPR is all API based. And then you try to invoke it, and there's this nitty-gritty details that the docs don't mention. Or when it comes to traceability, I was first introduced to DAPR by a colleague of mine who is very active in the .NET ecosystem. He was like, look at this, I've got my traceability for free, I did nothing and it works. And I spent 2 weeks and it still didn't work, only to find out that, yeah, that's right, we don't support it out of the box because we don't want to couple ourselves into either OpenTelemetry or Sleuth. Okay, well, you might just as well have mentioned that in that case. Why don't the docs explicitly say, by the way, you need to add this context right, otherwise it won't work. So for me, the developer experience, which this should all be easier for, right? Because that's the type of thing that we want to solve. It's just not on par to say, yes, this is the next best thing. Embark on your next project and make sure to bring DAPR with you. Anyway, we're going to wrap up. And there's a few things I would like you to take away from this session. So the first thing is, what is DAPR all about? It's all about building blocks that address common concerns for distributed applications. And they're mostly in terms of integration patterns. Secondly, this all works because of the sidecar pattern. Usually your motorcycle brings you somewhere. In case of DAPR, it's the sidecar that brings you somewhere, not the motorcycle itself, I'm sorry. And finally, DAPR, even though the package says there's a lot of good stuff included, it's not a one-stop shop. It's not a Swiss Army knife either. You still have to do a bit of plumbing before things work, and that really is kind of a disappointment to me. If you're curious about DAPR, I've got a do-it-yourself workshop which you can follow. It's up on GitHub, and there's a link for you. It also points you to the code that I've used using the demo, and again, I invite you to verify. It never mentioned things like Redis or RabbitMQ or any piece of technology that I've been using today. It's all it's all REST API invocation. And with that, I think we have a little bit of time left for questions, if there are any. And if there are no questions, I would like to thank you for your attention and wish you a very pleasant continuation of Jconf. Thank you.